In this video, I'll demonstrate how to find the C, M, and A, or the common, main, and auxiliary wires of a single-phase borehole motor. Our motors have clearly marked and color-coded lead-out cables. The C or common wire will always be black, and when new, we'll have a label on the end of the wire marked C for common. The main wire will always be blue, and when new, we'll have a label showing M for main. Finally, the auxiliary wire will always be brown, and when new, we'll have a label showing A for auxiliary. However, when working with pumps that have already been installed, possibly by a previous installer, or if the submersible cables have different colors to lead out, for example red, blue, and yellow wires instead of black, blue, and brown, we will have a test to confirm which wire is the C, M, and AE wire to correctly connect the pump to the control box. Here I have a 0.55 kilowatt motor connected to a length of submersible cable. And let's assume I can remember if I connected the wires correctly in the heat shrink joint. This would be a good example when a person would need to test for the CM and A wires. Let's begin by looking at the theory of testing for C, M, and A wires. Here is a representation of a borehole 220-volt motor. The motor is made up of two windings. Firstly, we have the main winding, and then the secondary winding, known as the auxiliary winding. There is a wire from a let-out cable connected to both the main winding and the auxiliary winding of the motor. This is known as the common wire or the C wire. The wire from the let-out cable connected only to the main winding is known as the main wire or the M wire. Finally, the wire from the lead-out cable connected to only the auxiliary winding is known as the auxiliary wire or AE wire. The best way to find which wire is the C, M, and A wire is to first test to find the C or common wire, because the C wire is connected to both the main and the auxiliary windings. That will make it easy to test for the M and A wire. Looking at the circuit diagram, we can see that the M and the A wire are connected through both the main winding and the auxiliary winding. So the resistance between the M and the A wire will be the highest, because it is testing the resistance of both windings. Let's remove the wire labels from the diagram. Now let's test between the top wire, the brown wire, and the middle wire, or the black wire. Let's say we get a reading of 16 ohms. Let's make a note and move on to testing between the black or middle wire and the bottom or blue wire. Remember, we are looking for the two wires with the highest resistance reading. Let's say we get a reading of 10 ohms. This is lower than the 16 ohms tested between the brown and black wire. Let's make a note and carry on. Finally, let's test between the top brown wire and the bottom blue wire. Let's say we get a reading of 26 ohms. This is the highest ohm or resistance reading, which indicates we are testing through both windings. This means that the brown and blue wire are the M and AE wires. We are not yet sure which one is M and which one is A, but if blue and brown are M and A, that means the only wire that can be the common wire is the black wire. So let's mark the black wire as C or common. The main or run winding has a lower resistance than the auxiliary or start winding. That means we can now test between the black or C wire and the other two wires to see which winding has a lower resistance, to identify the main or M wire. Because we already made a note to the resistance readings, we can see that the lower resistance is between the C wire and the blue wire. That means that the blue wire is the M or main wire. Let's go ahead and mark the blue wire as M or main. That leaves only the brown wire. So the brown wire will be the A or auxiliary wire. And we confirm this because the auxiliary winding has a higher resistance than the main winding. Let's go ahead and mark the brown wire as A or auxiliary wire. Now let's have a look at how this process would look when testing an actual motor. Warning: make sure to turn off or disconnect the power source before testing for the C, M, and A wires. In this case, my motor is not yet connected and is safe to test. I have made a printout of the testing sheet we use in the theory example, but you can also just make a simple note on some paper as you test the values. Let's begin by setting our tester to test resistance or ohms. This is a symbol for measuring resistance. So we can set the tester to measure resistance by simply turning the dial to the resistance or the ohm symbol. The position of the resistance setting may differ between testers. but a symbol will always remain the same. When practically testing for the C, M, and A, we will begin by looking for the two wires with the highest resistance. Let's begin by testing between the brown and black wire. Between brown and black, we get a reading of 15 ohms. Let's make a note on the side of the page and record the reading. Now we'll go ahead and test between the black and blue wire. Between black and blue, we get a reading of 8.9 ohms. Let's make a note on the side of the page and record the reading. Finally, we'll test between the brown and blue wire. Between brown and blue wire, we get a reading of 23.6 ohms. Let's make a note on the side of the page and record the reading. Immediately, we see the highest reading is between brown and blue. That means the black wire is the common or C wire. We can also see from out notes on the right of the page that the lower resistance reading is between the black and blue wire. And because we know that the main winding has a lower resistance than the auxiliary winding, we can go ahead and mark the blue wire as the M or main wire. Finally, we see from out notes on the right of the page that the resistance reading between the black and brown wire was higher than the resistance between the black and blue wire. Because we know that the auxiliary winding has a higher resistance than the main winding, we can go ahead and mark the brown wire as the A or auxiliary wire. And we have now confirmed that the wires were correctly joined in the heat shrink joint, and I will easily be able to connect the motor correctly to the control box.